Okay, so today we are going to finish the traveling salesman problem. So I'm going to begin with where we left off last time here, Hotel Fall 16. Hopefully I've already got that up. Here it is, Hotel Fall 16. All right, so let's just review high level what we're trying to accomplish here. We have a list of cities that we have to go to all of them. We're trying to figure out a reasonable route to go on those. And we talked about the fact that actually trying to calculate every possible route and choosing the shortest one, it's impossible, computationally impossible when you have 20 or 35 cities or 36 cities. Up until about 20, 25 cities, you can brute force this. But if you get higher than that, it's just not computationally possible with today's technology. So we have then, in this table, we have road distances between each of the pairs of cities. They're not really cities, there's hotels. Some of them are like only 1.63 miles apart from each other. And so that is the data that we're working with. We chose to solve this problem by building some arrays. And so here's the review of the code that we did on Monday. So we made this procedure called load arrays, and we declare a module level array called hotel. It's a string array. How many elements does it have in it? 36, right? It starts at 0, so 0 through 35. And so we put in the 36 hotel names here. How do you feel about this loop here in terms of that array? Are you looking at this structure going, I totally get that, or is there someone saying, you know what, I'd like you to walk me through what this loop does again? Anyone want me to walk me? I'd be glad to do it. Okay, so let's take a quick look at it. Let's remember what this array looks like conceptually over here in memory. So I have a series of variables. The name for all these variables is hotel, but because I've got to keep them separate from each other, I have to supply an index as well. So hotel or hotels. Is it hotel or hotels? It's hotel. I've got it just spelled right. So we've got 0, 1, 2, 3. Hotel sub 0 is this block of memory. Hotel, and when I say block of memory, I'm not talking about the cell. I'm talking about this is kind of a visual representation of what's going on in memory. Hotel sub 1 is a location in memory. So then what I have is this loop right here is saying, listen, we are going to execute this line 36 times. The first time, we're going to put a value into hotel sub 0. So this x will be 0 the first time through. So hotel sub 0 is going to get some value. What value is it going to get? It's going to look at the distance sheet. Cells 2 plus 0, so 2, row 2, column 1. So if I go and look at that sheet, I go to row 2, column, we're in hotel, column 1, yeah. So row 2, column 1, and it's going to pull in this value. So this is the Los Angeles city. So the Sheraton Los Angeles Downtown Hotel. And so it takes that value, Sheraton's Los Angeles Downtown Hotel, and puts it into the first slot in the hotel array, or hotel sub 0. And that's what I represented here. The loop then advances x, and so we're looking at the next slot in hotel. It'll then go to the next row and pull that value in as well. And so the next row is Salt Lake City. It's the Sheraton in Salt Lake City. And that's what I'm seeing here. We put in Salt Lake City. The next one's Phoenix, and so forth. So that loop is going to load up all 35 of these variables. Remember, the important thing to remember about an array is that it is an array of variables. Each one of these is a different slot in memory. And I identify them by the array name with its index. Okay. So we ended off with working this two-dimension array. So distance array is 2 dimensions. We can think of that as a grid, as we've done here. So we've got distance, and now, whereas hotel, I provide 1 index to talk about the variable I'm interested in. For distance, I have to supply 2 indexes. So if I think about this, I have to say, if I'm referring to this in VBA, it would be distance. And then in parentheses, I put 1 dimension, 3, comma, 6. Okay, so if I said that equals something, which cell am I talking about? Which of these am I referring to? Which cell is it? I'll narrow it down for you. It's either this one, or it's this one. Which one is it?
First one.
Let's vote. How do you say it's the first one?
What's the first one?
What's the first one? This one right here. How many say it's this one? How many of you say, no, it's the other one? How many of you say it's both of them? How many of you say it's either of them? actually, the correct answer is either. The reason is that this 3 and this 6 isn't really a row and a column. This is just the way that I'm visualizing this array. And as long as I visualize it consistently, as long as when I say the first one is O is the row, as long as I behave it that way uniformly, then this visualization will work just fine for me. So it could be this one or it could be this one, but it's just a matter of the convention. Am I saying that the row comes first or the column comes first? If that's a little too, if it seems too strange to you that it could be either one, then it's row and column. That's fine. Just always think of it as row and column, and that'll be okay. Because in memory, it really isn't a grid. It's just saying, here's two numbers. Great. I know which one that is. It's 3, 6. You could just think of this as a name. Okay. So now, nested loop. How comfortable are we with nested loop? How many of you look at this nested loop and go, that just melts my brain? So here's the important thing to realize is that everything that the loop is going to execute multiple times whatever's inside of it. So let's ignore this outside loop for just a second. Just look at this one. So how many times is this line going to execute with respect to this loop? 36 times. It's going to change the value of x. The first time it comes in here, x is going to be 0, and it will run that line. It'll then increment x. The next time it comes in, x will be 1. It'll do it 36 times, from 0 to 35. All right. So then it hits this next y. That takes us where? Well, let's think about this from the start again. Okay, so now we come here, and we're going to do whatever's inside this loop 36 times. So let's think about it. We come in here and we say, okay, we're just starting out here. Y is going to equal to 0. Y starts off as 0. And then we go here and it goes, oh, x is going to be 0 too. Y gets set to 0, and now x gets set to 0. So the first time this line executes, what's the value of y? 0. What's the value of x? 0. Okay, great. We hit the next x. That changes what? X makes it 1. We go back up to the top of this loop and start again. What's y? 0. Y is still 0. Y is not going to change until we hit this line. We don't hit that until we have gone through this one 36 times. So at this time, we go through here, y is equal to 35, or x is equal to 35. We execute this line. We hit next x. What happens to x? It goes to 36. It then comes back up here and checks and goes, oh, wait a minute. 36 is out of bounds. We're done. It then comes to the next y, and y is now 1. What's x?
0.
No, what's x? 36. X is still 36. This sends us to the top of the loop, and we hit this line. X is 36. We get to this line. What does this do?
0.
This pushes x back to 0 and says, great, execute this. And now at this point, y is 1, x is 0. Y is 1, x is 2. 1, 3, 1, 4, 1, 5, 1, 6, all the way to 35. It goes to 36. Doesn't execute the line with 36. In fact, as soon as it goes out of bounds, it's done. X is 36. We hit the next y. Y is now 2. X is still 36 until we get to here. X is now 0. Y is 2. So the inside loop is taking us across this dimension. And then when y is 0, then y goes up to 1. And the inside loop takes us across this one. The inside loop is reading across, or writing across, well, it's writing to the array across 1. And then we get the outer loop and it says, great, do it again. Change y, do it again. Change y, do it again. Did you get that okay? All right. So let's go ahead and run this. I've got to stop. So here's the stop. That's a breakpoint written in code. So if I run this, it should load that up, and I can kind of probe around at this. So let's take a look. I'm going to just look at distance sub 0. So let's look at that first row, comma 1. That should be the very first number in there. 691. Let's come back over here. There's 0, 1. Here's 691. Next one should be that 300 and something, 374, and that's fine. So now let's look at row number 1, column number 1. So we're looking for the value that's right here. Now, we read it off this sheet. Did we actually read this cell? We read that cell. We read that very cell right there. And so what do we think is going to print when I ask for, I'm sorry, row 1, column 0? When I ask for row 1, column 0. Yeah, it's going to be, it will be 0. Because when I take an empty cell and write that to a numeric variable, it goes, oh, I don't really know how to make empty into a number. 0 is the closest I got. So it makes that conversion. All right, so here's the thing. What do we want to be there? And we want 691 to be here. So here's the question. How do we do that? First of all, before we try how to do that, let's reduce the work that these loops are doing. So instead of, is there any reason for me to be reading this part of the data right here? What does that array start with? It's a numeric array. I've got an array of 36 times 36 variables. What is in that array when I first initialize it, when I first create it? There's something there. They have to be numeric values. They're single precision floating point numbers. Yeah, this thing is full of zeros when it first starts. So do I actually change anything when I read that cell and write it to the array? It's 0 already. We're going to put 0 into it. No. There's no reason for me to read any of these except the ones that have the numbers. So let's adjust our loop so it only reads the part with the numbers, shall we? Yeah. Okay, so let's think about what's the very first one that we want to read then. What are the coordinates of the array that I want to write to first?
0, 1, 0.
Yeah, row 0, column number 1. Now, what's the first one that I actually write to with this loop? 0, 0. Okay, so let's think about this one. So on the first row, when I'm on row 0, the first column I want to write to is column 1. When I'm on row 1, what's the first column? 2. When I'm on row 2, what's the first column? 3. Do you see a pattern here? Okay, so how could I express that? So instead of writing to column X, what should I be writing to? If I write to X plus 1, then I will always start, X is going to start off at 0, it'll always start writing at 1. That'll work for the first one, but if I do X plus 1, it's always going to start here. It's always going to start on this column. We're close. X plus Y plus 1 doesn't quite get it. Let's just think about this one. So here, oh, would it? No, it would start in the right place. It would start in the right place, but it would start skipping as I went. So actually what I want to do is every time when I'm on row 3, I want to start, or when I'm on row 3, I want to start on column 4. It's just Y plus 1. No. Hold on a second. Sorry, that's the wrong place. I want X. Sorry, wrong place. It's here. I don't want to start at 0. I want to start this at Y plus 1. Thank you. So the first time through this loop, X is going to start at 1. X will start at 1. When I get to when Y is 2, or when the next time through the loop, X is going to start at whatever Y is, 1 more over. And then it will continue to count up. Sorry, I was on the wrong place. This is where we want to be. So now, let's just go ahead and I'm going to do this. Just so we can kind of see this visually in the immediate window, I'm going to do a little trick here. Debug.print. I'm going to print a dot, just quote dot, quote, period, quote. But then, normally when you say debug.print, it prints that and then it does a carriage return, moves you down to the next line in the immediate window. I want to suppress that. I can do that by putting a semicolon at the end of it. That's kind of a weird way to do it, but that's what you do. Then when I'm done with this, I'm going to print, just do a debug.print by itself, which should print a line break. So this should kind of show me kind of visually how many times I'm executing this inner loop. So what I expect to see is I expect to see 35 here, then 34, then 33, then 32. This kind of should look like a triangle when this runs. So the first time that it ran, it did that bit. It put a period for each time that it was inside this loop. Next time, one less, one less, one less, one less. So we got down to the end. There's only one to read. In fact, I think the very last one, there was none to read. So we could probably adjust those numbers and shave it off, but it didn't execute it. Okay. So this may be the very first time that we have not just had a constant expression in for where the for loop starts. We can put any expression there to decide where that for loop starts. All right, so at this point, let's just go ahead and probe this a few more times. Distance sub 0, 4. So there's a value there, but now let's look at 4, 0. So I've got the number in one portion of the array and not in the other portion of the array. All right. So here's the question. When I write, let's see, here's 0, 1, 2, 3, 4. When I write that number, so when we have 383, 383. When I write this number, where do I want the opposite number to go? Right into the analogous position over here by the Phoenician, right there. How do I do that? When I write to 0, 4, I want to also write to what? 4, 0. Is that a coincidence? What if we tried another one? When I write to 1, 3, I also want to write to the Scottsdale. I want to write to here. What is that one? It's 3, 1. So what do? I just swap the indices. So right here, I can just do this same line again, but just change the x and the y. So we'll run that. Distance 0, 4, distance 4, 0. Now we've done that right. It should put the same value. So now we have that array fully specified. So yesterday when we were first talking about arrays, I said they can get more complicated. Have we made them more complicated? Yeah, this is the more complicated. Two-dimensional array, we're going across it in a nested loop, and the inner loop changes each time it runs. This is a little complicated. It's not terribly complicated, it's a little complicated. Okay, questions on this code? At this point, we've got the array loaded. Now it's time to actually use those arrays to start calculating our test. So what's our task? Our task is to actually calculate a route. So let's do this. I'm going to, up at the very top, I'm going to create now another subprocedure. We'll call this calc route. Or is it route? I don't know. Route or route. Either way. Let's start, when we run calc route, let's start off by getting our arrays loaded up. So we'll say load arrays. Ooh, I think I have a breakpoint in my load arrays. I'm going to get rid of that breakpoint, otherwise, I don't like that to change. Otherwise, this will stop right here. So let me get rid of that breakpoint so that when I run load arrays, it will actually load the arrays. And now I got to start working on the algorithm. So how am I going to do it? Any thoughts on how I'm going to build this route? First of all, I'm going to need some way to keep track of it. Go ahead.
So someone had mentioned just going to the shortest distance each time.
Right.
And then you had talked about last time that you just go back and forth, so we go to the shortest distance and then the next shortest distance.
So we need some way to be able to keep track of two things: what the route we were building is, and some way to keep track of where we've been. So let's create yet another array for this. I'll make this another array up here at the top. I'll call it route. And all I'm going to do is I'm going to put the index numbers in. So this will be an integer array. And I'm just going to put in hotel number. Hotel number 1 is where we start, Salt Lake City. And then I happen to know we're going to go to Las Vegas, which is hotel number 7. That's all I've memorized of this algorithm. It's going to be 1, then 7, then something else. But we'll use numbers. So dim route 0 to 35 as an integer. While we're running this, we have a little problem. What's this array going to start with? It's going to be all full of zeros. Now that might be a problem if 0 is one of our hotels. Is 0 one of our hotels? Come back here. Here's our hotel array. Yeah, our first one is hotel number 0. I'm a little bit uneasy to start my array out full of one of the hotels I'm going to try to go to. And so let's begin by saying, let's make sure we don't have a 0 in any of these. So since ultimately, I might want to expand this problem to go bigger than 35. So why don't we do this? When we're loading up the hotels, let's go ahead and initialize our route array as well. Route sub x is going to be equal to, what should we put? I'm just going to put -1. Doesn't matter how big I make my arrays, I'm not going to have an index of -1. I probably could make an array of -1. Starts with -1, but let's not worry about that. We're not going to do that. So this is just saying, you know what, I'm just uneasy having that all full of Los Angeles as the first hotel. Why am I uneasy about this? Because I've solved this problem before. I know I should be uneasy about this. When we get to the part that I was uneasy about, I'll explain to you why we wanted to do this. Okay. So now I have my arrays are loaded. I've got a bunch of -1s in my route. I've got a bunch of hotel names. I've got a bunch of distances. All right, so let's begin. In fact, I have found that quite often, in fact, almost all the time, when I'm writing code, especially code that's going to work with arrays and loops, to me it's always easier to start by saying, let me just start by actually putting in some real numbers and then worry about how to work those into a loop and an array later. So, how would we say start at Salt Lake? Just given that we now have another array here, let me plug another array right in here. And I will call it route. And we filled it with a bunch of -1s. All right, so how do I say start in Salt Lake? Yeah, I say the first location in my route is a 1. And then, when I go to Las Vegas, then I would say 7. And so that would give me the numeric, that will give me these numbers organized in the order that I want to visit these cities. So, help me out here. How do I say, just with one line, start in Salt Lake? Any thoughts? How do I make a 1 go into this structure in memory?
Route 0 equals.
Route sub 0 equals 1. Yeah. That deserves a comment, because it doesn't really jump out and say Salt Lake City. Start at the first hotel, or the second. Start at the, how about just start at Salt Lake? It's actually the second element in the array, but it's the number 1 element, because arrays start counting at 0. Incidentally, let me just throw this out real quick, because you might run into it. If I say option base 1 up here, my arrays will start at 1 instead of at 0. Which might seem like a really nice and easy thing to do, because you normally start counting at 1. But if you've learned arrays with base 1 arrays, and you come across someone else's code that's base 0 code, it will melt your brain. But if you've gone through the little extra trouble it takes to think about arrays starting as 0-based, you can switch to a 1-based array with no trouble. So we're going to start with 0-based. We're going to work with 0-based arrays. Okay. So now what I want to do is I want to figure out who's the next closest city to, where are we at? To Salt Lake. I want to find out who's the closest city to Salt Lake. Okay, let's look at our distance array and ask ourselves, answer the question, what algorithm, how do I figure out who's closest? First of all, which part of this table is relevant to us? Only a particular row, right? Right here, in fact, let me just go ahead and copy this value. In our array, we now have this value here. Is there anything else that I could possibly be interested in this whole array of numbers when I'm trying to figure out who's closest to Salt Lake? No. What's that? Oh, yeah. So, that's right. The data's in the second column. You're right. I couldn't look at this row or at this column because it's exactly the same data in both. But does this number mean anything to me? No, it has nothing to do with Salt Lake. So that's the good news, is I can immediately say, if I'm at Salt Lake, I can reduce the space I have to search through down to a single row of this array. What do I have to do? I just have to find the
smallest number.
Yeah, this is the first one. All I have to do is find the smallest number. So let's set out to do that. Let's make another let's make a function procedure. So this function is going to be, what shall we call it? Let's call it next city. And let's pass it a current city. And it's going to return a number that tells us which our next city is. So, our next city as an integer. All right, so here's the idea. We are going to pass down the 1 to this, and now we've got to figure out how to find the smallest number there. So, let's set out to do that. So I'm going to have to go across this array, so let's declare a variable to handle that, dim x as an integer. And let's go across that array. 4x equals 0 to 35. Next. Debug dot print distance sub. Which row do I want to go to? Which row do I want to go to? Current city. Okay, I'm passing in the city. But yeah, 1. I'm going to pass in 1 to start with. And then print column number x. All right. So I should be able to call current city, passing it a 1, and it should, well, it's a number, so it'll return a 0. I haven't told it what to return yet, so it will return 0. But in the meantime, it should print all the distances for me. Oh, sorry, next city is what the function's called next city. Oh, it's because I haven't, right now my arrays aren't loaded. So let me just, now by the time we run it up here, okay, let's do it. Let's put the call up here. We'll load array, we'll set the route to 1, and let me call next city from here. Route sub 1 equals next city, passing it, let's just pass it 1 for now. Okay, so now I should be able to run calc route, and it should print those off. We're still printing some stuff down in that load arrays, which we'll get rid of eventually. Now we can see that it is printing off all those distances. There it is 691, 3, 653. 691, 0, 653. That's the vector of numbers we're at. All right, so thoughts on how what we want to do is find out what the smallest number is. So how can we do that? Can you give me an algorithm that would do that? Some of you that have kind of started the homework, what do you thought? Okay.
You do it for each value of the array, and you set it equal to, if it's less than the previous value, then it will preserve that value.
Okay, so I gotta somehow find. I got some value that I can compare to.
Yeah.
And then I'm looking for one that's smaller than that. Look across all of them. Each time I find a smaller one, go, aha, that's my new smallest one.
Yeah.
Very good. Let's try that. So let me declare a variable to keep track of these things. I'll call it short distance. as a single. And let me call it short. I'll call it found index. I got to keep track of where I found it too, as an integer. Okay, so what you're saying is I'm going to come and look at these, and I'm going to say if the one I'm currently looking at is less than my short distance, then I found a new possible contender. So I'm coming along here. Let's say the number I've got so far is 800. So I come here and I say, hey, is this less than 800? Yeah, it's less than 800. And so that's my new next contender. And so now the next one I'm comparing to is 691. I come along, is that less than 691? Yep, that's my new next contender. 653. Is this one less than 653? Is this one less than 653? No, so it's not a contender. Is that less than 653? No. No. 653. Oh, 653. Yeah, that one's less. And so that's what I've got to do. So here we're saying if the distance that we're currently looking at is less than my short distance, then that's the new short distance. And short distance is equal to that distance I'm looking at. And I want to remember the x I found that out. So found index equals x. That looks pretty good. So here's the trouble. What does what does short distance start at? It's a number. It's a single. What is it going to start at? Starts at 0. Will I find the distance shorter than 0? That'd be a neat trick if you have negative distance. Great idea. So we need to start that off at some distance that is so big that anyone we look at is going to be smaller. Well, we're kind of bounded by the fact these hotels are on planet Earth, so we don't really deal with huge numbers here. What's the circumference of the Earth? About 24,000 miles. And so let's just set it at that. I mean, chances of having two distances that are hotels that are more than 24,000 miles apart, that's kind of crazy. You have to go around the whole Earth to get there, so that's not good. So let's set that as our first short distance. It's not a very short distance. But our whole key is that we want to pick up the very first one as a possible contender. 24,000. And the key here is it just needs to be some number that's big enough so that I pick up the first value that I actually looked at. Yeah?
Can you actually start with the first number?
Oh, why not just start with the first number? Why don't I just start with this number and then start looking at the rest of these? And if this was all we're trying to do, that would work fine. But remember, eventually that first number is going to be out of play because it will be a city that I've been to. Because we're not really just looking for the smallest number in this set. That's what the homework is. So that would work for the homework. But in this case, we're looking for the smallest city that is not in my route, that I haven't been to already. And so it's going to be a little more complicated. So I just, having done this a time or two before, this is going to be a better approach for us. But that's a good idea. You're right. I can just start with the first one, and then I don't have to compare the first one. I can just look at all the ones, over. And for the homework, that's a great approach. Question?
You may have said this, but I'm not quite sure. Why do we do found index? Are we later going to do something with that?
So what we have to do, right, in your homework, you're just trying to find the smallest number. In this problem, we're trying to find where is the smallest number located. So when I find the smallest number here being Las Vegas, where's Las Vegas? Las Vegas. When I find this one, I'm not going to return 425. I'm going to return 7. I'm going to return the index number of the column I found in. 0, 1, 2, 3, 4, 5, 6, 7. So I need to keep track of that. So let me go ahead and that's what this does right here. So found index is the index that corresponds to the shortest distance I've found so far.
What do you do with that?
ultimately this function is going to return it. So the way this function is going to work is I send it a city that I'm working on, and it's going to send back the number that corresponds to the next city. Why? So I can put that
Gotcha.
as the next number into the route. That's what I meant. Go ahead.
For the short distance, you set that default max value. Did you not set to like the first value in the array?
So could I set it to the first value in the array? What do you think? That would work really well for the homework, but because this is going to be more complicated, because that first number may or may not be in play. Because if it's a hotel I've already been to, I can't just look at that first number. So it would be a lot more complicated, because I have to say the first number that I haven't been to, then set to that one, and then go from there. So, yeah, this one. What this will do is this will cause it so the very first time I read, it plugs in the first number instead of starting with it. But no, that's a fine way to do the homework. Go ahead.
Can we assume that the data, like each part of these arrays, will be castable to an int, or are you going to throw some dirty data like strings or something like that in the lists when the grader runs?
Oh yeah, you can assume that. Okay, so have you actually looked at the code for the homework yet?
Yeah, I have.
Because the code, there's a lot of comments in the code on this, and it kind of takes you through that. It actually cleans the data before you get to that. So the part that you're writing the homework, you can assume that it's clean data because it will actually clean it before you get to that. Does that mean you're actually working the homework right now? Maybe. Okay, just check. So let's look here. Okay. So actually, I think that's it. Oh no, one more thing we got to do here. We've got to return found index. After we've gone through this, found index is going to be our smallest value. We've got to set the function to return the found index. Now we haven't done anything yet to say don't consider cities we've been to already. But let's go ahead and run this and see what it returns. So I'm going to come and put a breakpoint in my end sub. I'll run my main procedure here. And let's look and see what's in Route 1. Route 1 is 1. What does that mean? It says Route 1 is 1. What is that actually saying? What information is that conveying to? Yeah, it says Salt Lake City. It says start at Salt Lake City, route sub-0 Salt Lake City, and then go to Salt Lake City. Why did it choose Salt Lake City?
It's the closest zero.
It's 0 for crying out loud. It's the smallest number. Yeah, it really found the smallest one and returned the number. Now, it turns out, have I already been to Salt Lake City? Yeah, Salt Lake City is already my route. And so let's exclude people who we've already been to. So, before we even check the distance, let's first check to see, is this a place we've been to? So, we'll make another function for this. Function. Been there. I'm going to pass it the city as an integer. Oh, I should probably put types on this as well. Current city, no, I did it right. Yeah, current city as integer, that's right. Function city been there as integer. All right, talk to me. How am I going to tell if I've been there? What does it take? How do I know if I've been there? Talk to me in terms of algorithm. Nope, don't talk to me in terms of VBA code, but just talk me through what we've got built so far. How can we do it? Go ahead.
So if you look at everything in the array up until where you're at and see what numbers it's returned, exclude those numbers from your current search.
Okay, so you're saying look at the route array.
Right.
Okay, so here's the thing. At this point, if I think about here I am in my next city. I'm working on a current city. Oh no, I'm sorry. Right at this moment right here. So I've got x. So x equals 0. I got to ask myself, have I been to city number 0? Right? And so I'm going to pass down the 0 down to here, and then bin there is going to work with this route away. Where does it have to look to see if we've been to city number 0?
Just in that array.
Yeah, it's just going to look right through here and say, is 0 anywhere in here? This is why I wanted to make sure we got rid of all the zeros. So if 0 is already in this route array, then I've been there. Otherwise, I haven't been there yet. So this is actually a pretty simple procedure. Let's dim a control variable, dim x as an integer, where x equals 0 to 35. Next, if route R-O-U-T, sub x is equal to the city that I passed down, then we found it. Right? Then that city is in the array. We've been to that city. What do we do if we've been there? Well, this function just returns true or false. Let's make this a Boolean. This function just returns true or false based on whether I send it a number, it just says you've either been there or you haven't been. So here we found the city. What do we want to do? Set the name of the name of the function equal to true. We've been there. And the name of the function's been there. We could name the function not been there, but I like been there better. Too many negatives, it's hard for me to think of. Now, once we've been there, is there any reason to keep looking through that array? No. What are we going to say? It's been there twice. We've really been there?
Exit 4.
Yeah, so we're done here. Exit 4 or exit function, either one. Now, what will it return if I never hit this line? The default value for Boolean, which is false. So if I never hit this line, it will return false. That looks pretty good. So now, even before I'm checking to see if that distance is a contender, I want to say, have I been there? So I'm going to give myself a little space around that if statement. I'm going to tab it in a level. And I'm going to say, if been there. Now, what do I pass down to it? There's kind of two contenders here. Do I pass down current city or do I pass down X? Yeah, I'm going to pass down X. By the way, is current city going to be there? Yeah, current city will be there every time. It's the one I've just been to. Right, up here, I'm going to put the current city in the route and then ask for the next city. Yeah, current city will always be there. So what we're really wondering is, have we been to X? So if been there, X equals true. Then we need to check to see if it's a contender. Otherwise, there's no reason to look. It's not a contender. Doesn't matter how small the number is. It's not a contender. Wait a minute. Wait. If been there is equal to false, yeah. Or if this actually reads a little bit better. If not been there. Right? Because if this returns true, then this whole thing will be false. And then we won't execute what's inside. So if not been there, check to see if it's a contender. If it is a contender, then record where it is and move on. Ow. Okay, I'm going to run this again. I'm going to run my calc route again. Now let's see what's in route 1. Hey, we got 7. Incidentally, how would we show the name of that hotel? If I pass a 7 to my hotel array, it will give me back what's in the number 7 slot, which is the name of the hotel. So here, I can actually use one variable to tell where to look in the other array. That's kind of handy. So that tells me, okay, the next place I'm going to is Las Vegas. I have never taught this so fast before, which makes me think, usually at this time we got like 5 minutes to go, which makes me think I might have blown through this too fast. How many are going, that was way too fast? You got a video, you can go back and okay. How are we? So let's kind of pick up some ground here. How are you feeling about the bin? We can talk about this for a minute. How do we feel about the been there city? The been there. How many of you are saying been there? I totally get it. How many of you are going? I could use a little more help on the been there. All right, go ahead.
Mostly for me, it's just keeping all the variables straight and raised. There's just a lot of different things for everything.
A lot of stuff is going on.
Yeah.
Yeah, that's true. I have two daughters. They're both kind of artistic. And my one daughter was kind of showing something to my other daughter. I forget what it was now. But the one daughter who's learning it says, "Hey, slow that down. I can't quite see what you're doing. Slow that down." And she tried to slow it down, and she said, "I can't do it if I slow down. Can't you just watch faster? Can't you just watch faster?" Unlike my daughter, though, I can slow this down. So let's take a look at it. So let's think about what this function is doing. We've got a loop right here that's going to loop 36 times. Right, it's going to go from 0 to 35. We are going to be looking at the route array. So we're going to look at every element of the route array. So here's my kind of visual representation of the route array. So I'm going to be looking through each one of these. How do we feel about that part of this? About that part of this assignment? About that part of this solution? Just this for loop. We see how that loop is going to look at every element in the array? Okay, so now we have sent into this function, we've sent in a number. Let's say it's a 7. We're checking to see if the one I'm currently looking at is equal to the one I passed in. I'm trying to find out, did I find, if I passed in a 7, it's going to look right here. And it's going to say, does 7 equal 1? True or false? False. 7 equals 7. True or false? True. So right here, when x is 1, we're going to be comparing route sub 1 to whatever we passed in, supposing it was 7. This would be true. That means we found it. We're looking at everything in the array. We found it. There it is. Once we found it, all this function does is tell us yes or no, true or false, been there or not been there. And if we've been there, if we find it, we set this to true, and we're done. It just lets us out. You doing okay with that now? Has that made it so much better? I remember when I was a student, I was taking a statistics class, and the professor didn't speak a whole lot of English. And he wasn't very good at explaining things. We were talking about something about regression. He said something, he said, "Do you understand this?" And I finally said, "No, I really don't get this." And he proceeded to prove it mathematically, which was absolutely no help to me. And about halfway through the semester, I realized every time we say we don't understand, he proves it to us. So finally I had to tell him, "Professor Wu, I believe what you're saying. I really do believe that this is the way it works. I just don't understand. Don't prove it to me. I believe it already. Maybe give me some intuition to this." I hope I'm not just proving this to you. Questions on this one?
I just have one. City, do we have the... Where does that come from? We don't dim it anywhere.
But we do dim it. We're declaring it right here.
Okay.
So remember, this is a special kind of variable called a parameter. Parameters get their value when the function is called.
Okay.
So up here, I'm going to call this by saying, if here's where I'm calling bin there. This calls bin there because I've got a parameter, a variable set up right here to accept a value. I've got to give it a value here.
Okay.
So up here on this loop, we're going from 0 to 35 here. This is going to allow us to look across this array to get to find the shortest value.
Yeah.
So this loop now is going across that one row of the distance array, and it's going to say, all right, when I'm looking at a particular, well, I might think of it as a column. I'm looking at a particular column in the distance array. I want to know if I've been there. So when I start this procedure, I'm going to come in here. X is going to start off at 0. If not been there, X. Let me set this back to where it would be. So at this point in our algorithm, this is what our route array looks like. It's got a 1 and a bunch of negative 1s. So if not been there, X. What's X the first time I come through here? X is 0. And so I'm looking right here at this cell right now, and I'm asking, is 0 in the route? That's what bin there tells me. Bin there tells me if the index I passed down is in the route or not. So the first time I'm trying to figure out, do I have a new possible contender for my shortest distance? I'm going to come right here and say, hey, if not bin there, I'm passing it down to a 0. Bin there is going to look across the array and just return true or false based on whether 0 is in here. It looks across this whole thing. Is 0 in there?
Nope.
0 is not in there. And so it returns. Yeah. So this is going to return false. So this part is false. That means this whole part is true. Yeah, that's a city I haven't been to. So I want to check to see if that's a possible contender. Now, my short distance, the first time I hit this line, my short distance is 24,000. So I'm comparing now 24,000 to the distance array at my current city, which is 1. I'm passing down Salt Lake City, compared to the distance to Los Angeles, to the number 0 city. I'm looking at that cell right there. And I'm asking the question, is 691 smaller than 64,000? True or false? 691 smaller than 64,000. True or false? True. That's what this says here. And so at this point, I found a new possible best contender. And so I got to record that new short distance, which is now going to be 691. And I've got to remember that I found that at index number 0. Now I come back to the top of the loop. I hit this next. I print here. I hit this next. That changes X to 1. I then ask, have I been there? I send 1 down here to bin there. Bin there looks across this route array, and it says, all right. I immediately go, wait, there's a 1 right there. So have I been there to 1? Yep. This thing's going to return true. So we find a match. We return true. Come back up here. This part is true. So this whole expression is false. So now do I even look at this as a possible contender? No, I don't even come into this part of the code at all. I skip by it. I hit the next X. Now X is 2. Have I been there? Look through this. No 2, so been there equals false. So not been there equals true. And then consider that as the next contender. Do we see the algorithm? Do we follow it up now? Okay.
Yeah.
How many of you are going? That's better. I think we can go on. How many of you are going? Cheryl Cannon explains this better in office hours. All right. So now, at this point, we've got the next city. So let's just kind of do the next part of the route by hand before we think about making this into a loop. So route number 2 is going to be the next city. What do I send down to it? 7. And let's go ahead and run that and see what it pulls back. Route number 2 comes as a 12. Let's just do a quick check and see if that makes sense. It tells us it's number 12. So I'm on this one. Now let's see. I'm on Las Vegas, so I've got to find Las Vegas. Here's Las Vegas. I'm going to go to the 12th position. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's telling me that 273 is the smallest number it found. Or 237, thank you. So I'm just going to kind of scan across that and find, do I see one smaller? 281, bunch of 200s. 5, 5, 5, 5, 5, 12. Yeah, that looks like the right one. So we're feeling pretty good about that. Let's do one more by hand, then think about the loop. So let's see what else it's done here. So what else did that do over here in route? That put in, now we have a 7 here and we have a 12 here. So now, to find the next one, route number 3 is going to be the next city from 12. I'll run that one, we'll look at route number 3, then we'll think about the loop.
What are you doing there with the arrow? You're dragging up there, and so what is the code?
Okay, so the question is, what witchcraft am I doing here with this yellow arrow? The answer is I've got a breakpoint here on n sub, so my code never finishes running. I'm still in break mode. This is the next line that it's going to execute if I just tell it to start running again, if I just click play. But I can say, that's my current statement. I can say, you know what? No, I want to go back to here.
You're
start running from here.
You're starting there?
No, it's currently running. It's suspended in memory. I'm just continuing from there.
Okay.
Yeah, so all this stuff is running. I'm saying, you know what? I want to go back and do this one. I really liked this line. I want to do this one again.
Okay. Gotcha.
Okay, so let me look at route number 3. That brought back a 19. And we can go verify that that's the smallest number on 19. It might not be the smallest one. Why not? Well, there could be one that I've already been to that's closer, but that's getting... So what I have to do is I've got to come up with a loop that will do this. This part looks easy. 1, 2, 3. This part looks hard. 1, 7, 12. How am I going to do the 1, 7, 12? How am I going to get a variable or some kind of expression that will produce 1, 7, 12? Yeah.
You want to get the route from the previous index.
Yeah, where do I see that 1, 7, 12? Let's take a look. 1, 7, 12. That sequence is actually what's in the route array. So my 1 is route sub 0. My 7 is route sub 1. So it's route sub 0, sub 1, sub 2. Let me just plug those in and see what it would look like. Route sub 0. Route sub 1. Route sub 2. So now these lines look exactly the same except 1, 2, 3, 0, 1, 2. That I can deal with. So let's make a loop that does that. X as an integer. Why am I using X in every single one of these? Isn't that a problem to use X on all these? No, because when I declare it inside that sub-procedure, it makes... I can have all of these in memory at once, all named X, but they only have meaning in each one of those sub-procedures. You might even think of it as the sub-procedure name .x in memory. So to me, anytime I use like a single letter variable, it just means it's a local variable that I'm just probably using for a loop and doesn't have a whole lot of meaning. Okay. So now, DMX has integer, and I'll make this into a loop. Where x equals 0 to 35. Next. I'll bring one of these lines in. Okay, x starts at 0, so this will be x plus 1. So this is 1 the first time through, and then this will just be x. Oh, actually, I don't want to go to 0. Sorry, strike that. I don't want to start at 0 because I just set the route. I just set 0 right here. 0 is already set. So let's start at 1. We'll go 1 to 35. Let's make this x, and let's make this x minus 1. So now this should calculate the whole route. Why is it printing off so much? We must have a debug.print down here somewhere. Here's a debug. That's what that print is. I don't want that. Okay, but now we should be able to kind of look at our route. What's route sub 3? Route sub 3 Oh, actually, I already had a route partially built when I ran this. I better stop this thing and run the whole thing again. Let's look at route sub 3. Should be 19. Route sub 4 should have a value, 20. Route sub 5, 10. It's giving me a route. Shall we print the route out so we can see it in English? We could print it out right here, but I'm going to use a separate loop to print it out. We'll go from 0 to 35. And we're going to do a debug.print of debug.print hotel subraute sub x. This is kind of abstract here. But remember, the route holds our route. 1, 7, 12. If I take a 1 and pass it to my hotel array, it tells me Salt Lake City. 7 tells me Las Vegas. So hotel sub route sub x will just give me the route in the names of the variables. I'll run that again. And that should be our route. Let's check it for some reasonableness. We start in Salt Lake City, we go to Las Vegas. So far, so good. From Las Vegas, we go to Sheridan Suites Fairplex. You don't know where that is? Let's assume it's somewhere close to Anaheim. We're going to Anaheim. That's Los Angeles area. That looks pretty good. Oh, next one's is also in Anaheim. That's pretty good. Cerritos. Anyone from this area? Do you know how close Cerritos is to Anaheim? We could look it up. We have a chart on the next page that will show us that. But it's Los Angeles area too. Long Beach, Los Angeles, Beverly Hills, Los Angeles Downtown Hotel. It's a little bit weird that we're going from the airport to Beverly Hills to downtown, but Los Angeles Airport could be kind of away. Maybe Beverly Hills is on the way to. Monarch Beach, I don't know where that is. La Jolla, I know that. That's San Diego area. San Diego, Horton Plaza, San Diego, out to Palm Springs. Anyone know where Palm Springs is? Isn't that kind of like straight east from LA?
Yeah.
This is a little strange. So we came down from Las Vegas into LA, San Diego, now back out to Palm Springs. Okay, maybe that's good still. Bakersfield, more Northern California, San Jose, Bay Area, Silicon Valley, Pleasanton, don't know where that is. San Francisco, Silicon Valley. This looks pretty good. We kind of went up the West Coast. Mark, San Francisco, San Rafael. Sounds like Silicon Valley. I don't know. Sacramento. Now up to Seattle. So far, so good. We didn't go to Seattle, then San Francisco. It's looking pretty good. Seattle. Somewhere else. I don't know. I don't know where Kierland is. Uh-oh. Scottsdale. Phoenix. I started in Salt Lake. I went to Las Vegas, Los Angeles, San Diego, then back up the coast. That probably wasn't as efficient as it could have been. Probably should have gone to Palm Beach, then to San Diego, then up the coast, but back down to Phoenix? What would be better? Las Vegas, Phoenix, across and up. That'd been way better. That would cut off a trip from Seattle to Phoenix. That's a long trip. Is this the best route? No, but it's a reasonable route, except the Phoenix part. How could we have done this better? With a map and a pencil. We really could have. Why don't we do it with a map and a pencil? For this task, you got to figure out one route. You probably would. But if you've got to route 10,000 routes for a shipping company every day, you do it with a map and a pencil? No. How long does it take to calculate this route? Less than a second. Run this whole thing? How long does it take? Most of the time, let's see, most of the time is printing out to the screen. It runs in dramatically less than a second. So that's the idea. Our whole task here, though, was having kind of a realistic problem to work that has a reason for us to dig into arrays and to work for arrays. That was the folks, you've got a project that kind of is based on this. It's due like 2 weeks from Monday. You got some time on it. It's pretty similar. The idea is the game of Big Boggle. Have you heard of it? You heard of Boggle? Go ahead and stop recording. The class is over.